We need to confirm this result. This was a time domain method. That was time domain method, what we just done. It's a lot easier way to do it. Z transform method that we're going to do next. That's part D. It's another 6 months for that.
And I can't believe you spent like half an hour doing that one.
So what if we did Z transform for part C?
You get no, you get
Part D, actually use Z transform.
Then you'll definitely lose correcting.
definitely. Should be correct.
Well, the answers are the same from the revision.
The proof, you may see different proof. Like if you go to Alex Hunt, he's probably going to give you some easier
faster
method or faster way, but
we had to figure this out by
we
ourselves.
figured it out ourselves.
So,
We deserve a snake bite. No,
Anyway, so we just solved like a £1 million question.
no, it's not £1 million, it's only 6 mark question.
I don't like it.
Free
How can we
grant.
solve it?
Free grant question. It's worth all our tuition fee, that one. So,
do it.
so, using the same thing, yeah, xn xn was
Did you do your X's properly?
God, it's x. X meant to be like that.
Fine, we just do times using dot then.
You want like that, yeah?
No, just use times using dot. That's fine.
Yeah? You want x
Just
like
use,
that, yeah?
just use a dot for times.
No, that's
Easy.
weird.
Delta n minus 0.3 delta n minus 1.
Delta n minus.
Yeah,
Yeah?
that's just Z transforms. You have to do it.
From the table, we know delta n,
Table.
yeah, goes to z minus
N.
to the right. Okay, this minus. So,
I did that.
remember that from the table.
Is it given?
It might not be given, it might be very unclear on the table. So from that, we got our shift is 0, so it will be z to the 0 is 1 minus
So what do you say?
0.3 times z to the minus 1. That's basically your x offset. I do it like this because that's a notation you need to use. Fine.
You happy now? Happy with the X?
Yeah, very happy. Thank you very much.
So that's our x offset.
Okay.
We already got the h and z from the first question. It's given in the question, so h of z equals 1
H is X, it's not a function.
of z of minus
It is
1
a function of what?
plus 0.06 z of minus 2.
H of Z.
Yeah, function.
Factorizing that again, as we know from the last question, is 1 minus
0.3 Z.
0.3 z minus 1. 1 minus 0.2 z minus 1. So, and as we, y of z, yeah, y of z
Can you see what's going to happen now?
equals convolution in time domain, I'd write it down. H of, oh God, no. What was it? X of n.
I'm almost certain that's z minus 2.
Which one?
That bottom one.
Are you sure?
What would it be minus?
No, it's actually if you multiply it out. No,
Yeah,
it
so
makes
you
sense.
get
Yeah,
that
yeah,
square.
multiply out. Yeah, no, okay.
Yeah. Xn
It's just that he's
Convoluted.
he's printed
Yeah, I
it
think
wrong.
you did
He
it
must have been
wrong.
done wrong.
You did it wrong.
H of n,
Which is helpful.
yeah, equals to the x. Oh, that's a drawing mission. And h of z.
Copy that.
So guys, basically,
Can you see what's going to happen if you do
convolution,
X?
convolution in time domain equals to multiplication in z domain. That's basically it.
Can you see
So
what's going to happen?
yz,
What?
Good factor.
No,
Is-
if you do y z times h z, can you see what's going to happen?
Where's Y Z?
It's just going to go on the numerator.
It's going to cancel out. So 1
And then cancel, yeah. Yeah.
so that gonna equal whatever that was.
So it's 1 minus 0.3 z minus 1
No, minus 0.3 z to the minus 1.
over 1
Mate, just write it on one line.
He will be in one
Which
line, don't worry.
equals 1 over 1 minus 0.2 z to minus y.
Can you transform that?
And basically, these two gonna cancel out.
Yep.
Yeah. As we expect,
Mm.
because we just want that term left. Yeah, those two gonna cancel out. But
So
your
what
y of z gonna equal 1 over 1 minus 0.2 z minus 1 from the table. Again, from the table,
Table that we created.
that will equal 0.2 to the n of u of n. So that is our y of n, and that is our y of z. So from that form, we can get this generic formula. That if you guys want to remember it, remember it. If you don't, don't. Because z to the minus k over 1 minus b of z minus 1 will equal to b to
Is that
the
your formula?
n minus k times u to the n minus k. Remember that formula, it will help you. It's a generic form.
I think that's actually in there for once. See this one?
And in this case, we assume that 1 is equal to z to the 0.
Fucking useless.
So z to the 0, if you try it, z to the 0, it will give you b, would be 0.2 to the n, un. So your k is 0 in that case. That will work with every single case. And I worked that out last night, 3 hours, till 4:30 in the morning. I worked that formula. It's not really that popular, that formula.
Is that your
It's
formula?
not in the table.
So you didn't work it out, you found it.
No, it's not in the table. I don't see examples and I
Are we all supposed to
found
know
that it
it?
works for every case.
Is there an easier one?
No! Fuck's sake. Just
And
read
did it say to
Come on.
find yn for 3 different ways, right?
Yeah.
Did it ask for this as well?
No, you didn't ask for it.
So that's another 6 marks. As you can see, it's so much easier.
Wow.
And that should be the same as the answer you got for the previous answer.
Yeah, that's what we got.
So if you haven't got the previous answer yet, you just
Yeah. That's what I done. I done this one first and then the other one. This one works every time.
Oh, so when you do that, you can multiply.
So what form are you using that table? Actually, no?
Probably.
Delta n, we got that.
Times together.
Delta n goes to 1. But he gave you a wrong formula because that's the form you need to use it, see? Because if you got delta n on this side, because the shift is 0, you're going to be z to the 0. And gives you 1. But if it's minus 1, then it's going to give you z minus 1. Don't know why he gave you that formula.
Which one? Oh, in the table.
Yeah.
Yeah, he says it just reverts back to the unit step, but that's because he's got no constants in.
Yeah, you got no
Yeah.
constants.
That confused the shit out of me yesterday.
Yeah, it's the same with integration, they never give the constants formula.
So these two rules, yeah? These two identities we need to remember. And they work every single time. Right, that one and that one.
What, that one will come, that
In
one?
the black box and the green box.
That one and this one. And that one you should know it anyway.
Yeah, yeah, that's.
You should know that as well. There's another one, convolution in Z domain is the same
Green
as
stuff given the
multiplication.
table, yeah?
So
Nothing is given in the
Oh.
table.
Compare
table
and
is crap.
justify your results.
if they are the same, they're the same.
They're the same, and I just say that transform like this.
Compare, you could say that
So you just have to
inverse Z of yz in question D was equal to yn in question 1.
What do you mean by justify?
We justified it already, the first one, didn't we? That's what it is.
I was just going to say, answers are the same, and
Yeah.
using Z transform is a lot easier.
Yeah.
That's it, 2 marks. Compare, they're the same. Justify, Z transform is a lot easier.
You could say, I just done it.
I'm annoyed he's gonna. I think he might throw in a butterworth filter one. I really do, because it's such an easy question. But he said he was going to do question 2 and 3 for us.
That one we just done, right?
Yeah.
He said he's gonna do.
Yeah, he says he's going to do that one and the one after.
So So guys, how do we think we can justify this? We compare it all the same, but how do we justify it?
Justify saying that transform one is a lot easier to do.
No,
That
that's not
doesn't
justification.
justify what the answer we got. That doesn't justify it. It should be like a generic rule to find out. There is a.
So they are the same.
What you could do is you've already worked out the stability, haven't you? So if there, because there's no impulses on the left-hand side, it's all on the right-hand side, then it's stable as well. So they're both stable. You could say they're both stable. So you've already justified the stability. That would be some way of getting it.
Yeah, we could say that. And another thing, guys, for stability, like in S domain, that was when we said it was a stable from control system.
Yeah, on the left.
When it was that, right? When the poles, we didn't care about zeros, did we? It was only poles we cared about.
Yeah.
When it's there in S domain, it was a stable. In Z
That's
domain,
the unit circle.
that is that unit circle.
Yeah, but it's, so it's between -1 and 1 then, isn't it? Between -1 and 1.
You could say in the x-axis, you could or z-axis in this case.
Yeah. So
It's
between
in
1 and 1.
between -1 and 1.
Yeah.
But
Shall I do an autocorrelation example?
yeah, we could do autocorrelation.
We looked at shit. We looked at the one from the coursework.
Yeah.
Yeah, we could go through the ones.
So they are the same well done like that.
I'll show you what I think he's done, and then if you don't think it's this, then you can let me know.
So, has everybody got this down, yeah?
Yeah, that's all good.
So what's the then? They are the same, their transform is easier.
Yeah.
No, I'd say that it's stable as well, because if basically he said that if you've got an impulse function that is like that,
And
you've got the axis there, and you've got all the impulses on this side, then it's stable. If they're on this side, then it's not.
Okay.
And in this case, all the signals are going to be right.
You've already worked it out
Yeah.
that it's stable on the previous one, so you can say using that form, and that is right, isn't it? It's
Yeah.
the unit step will be on the right hand side. So
Yeah, exactly. I was about to say that. Unit step will not work. That unit step function we have will not work if the value is less than 0.
yeah, exactly. So it's got to be stable.
Show
I think
me.
that's what he said.
So it's D and D and stable, yeah?
That's right. Well, yeah.
They're the same anyway, B and D.
So you could just say that they're the same.
Let's say they're stable.
I think saying that they're the same and they're both.
So, convolution, yeah?
Right, yeah.
Well, somebody who got good handwriting,
Hamid,
please
shall I
write the
pause it?
question in the
Shall I
right.
pause it, Hamid?
Sorry?
Yeah.
Your iPad.
Yes, please, pause it. You can't pause it, you got to stop recording. You will save it and you got to record again.
Just press the red button. Press the red button.
Yeah.